All right, so this is going to be a video on conversion from logarithm to exponential and exponential to logarithm. This is something that's just kind of like a refresher if you've forgotten how to do it, or if you missed a day and this was the day that you missed. Hopefully this will help. I'm going to start exponential. When you have an exponential, you normally have a base, and then it normally is to a power, and then that equals a number. Yep. Okay. If you were to rewrite this as a log, you can take each of these three pieces and they go into the log sentence, and what you end up with is log, and that doesn't change. The base is a sub number that goes here, so it's below, and then the number that was what the base to a power was equal to goes here, and then the log base of a number is always equal to, it's like a fun game of how many markers I can hold, the power. Okay, so that's just the conversion formula, and you can go back and forth between these two. So if I gave you a log, you could rewrite it by taking the base to the power equals the number. If I give you an exponential, you can take the base and turn it into the sub number on the log. The power is what it's equal to, and the number goes here. Now, where it usually makes most sense is when we do an example of it. So let me do an example of this situation. So say I have, I'm going to start log and then go to base or to power exponential, and then we'll go back. So say I have log base 9 of 81 equals 2. Okay, and I didn't color code it. But what I think about as I'm doing this, and this is why the words to me are really important, is I always in my head want to think log base 9. Because the base is always going to be what's being taken to the power. So if in my head I'm always remembering this is log base 9, I know that when I rewrite it, 9 is my base. All right? Then I remember that log is always equal to the power. So I know 9 to the second power equals the number, which is 81. All right? So if you look at it, base to a power equals a number. Base to a power equals a number. When it's written in log form, it still means the same thing, but what they do is they sort of undo each other. And what happens is the log base 9 of 81 is 2. All right? So if I were to give you the log, you could rewrite it as the exponent. If I gave you the exponent, you could rewrite it as the log. Now I'm going to do like 2 or 3 more examples, and that's really it for this video. If you find that you watch it and you're not 100% sure, like when the problems get weird or when there are lots of variables involved or anything like that, we can always look at it. So I'm going to erase the format, and I'm just going to do a couple of examples. Normally you will not do them together, so it might be more something like this. Write each log as an exponential. And then the next one would be write each exponential as a log. Okay. You wouldn't generally do them all in one problem because the instructions are different. What you want to think about is, if it's a log, I can write it as an exponential. If it's an exponential, I can write it as a log. I feel like this marker is not very bright, so. All right, this is a log. And this is a true log. This next one I'm going to use some letters so you can get used to looking at it if it's got letters in it. Okay. So think about when I say it, when I use the words. Log base 4 of 64 is 3. Okay, log base 4 of 64 is 3. So what is my base? Okay, my base is going to be 4 because it's my log base. Now, I always remember log is equal to the power, and it doesn't really make sense. 4 to the 64th power would be way too big to be 3. So if I know 4 is the base, I really have to stop and think, does it make sense to take it to the 64th power, or does it make more sense to take it to the third power? So I would say 4 to the third power is 64. Okay, now this next one is trickier because you can't think like, oh, do the numbers make sense? So you have to know the form. Log base m of 27 is n. All right, so my base is my log base m. And here's where it helps me to remember that log always equals the power. So this n is going to be my power because log always equals the power. And then whatever this number was that was there goes at the end. Okay, so that is log converted to exponential. Now you can do the reverse. Let's see if this marker works. Oh, it does. How nice. I don't know, let's do 2 to the 5th power equals 32. And let's do x to the y power equals 13. All right? So one that is numeric and makes sense, and one that is letters, and so therefore it can be a little confusing. But it's really all about the form. All right, you always write log, and then next to the log is our little super number, which is our base. The base of this is 2 to the 5th power equals 32. What's being taken to the power is the base. Now, here's where I remember that log is equal to a power, so I know the 5 is going to go there. Therefore, the 32 has to go here. Log base 2 of 32 is 5, because I think to myself, 2 to what power is 32? 2 to the 5th power. Okay, this next one. Log base, okay, what number is being taken to a power is x. And then I stop and I remember, oh crap, this one's not going to make any real numeric sense, but I know that log always equals the power. My power is y. Therefore, the number has to go here. So log base x of 13 equals y. You aren't yet solving. You aren't yet using any properties. This is literally, can I understand the relationship between the exponential form and the logarithmic form? Right? As you move forward in logs is when you start to use properties, you expand, you condense, and eventually you use these properties in this concept to solve. All right, I hope that helped, and have a lovely, lovely evening, day, afternoon.